Greetings everyone. Today we're exploring logarithm basics. We're finally going to learn about logs. And in this particular video, we're also going to include natural logs. And so if you are looking me up on YouTube, just make sure you're on the correct video. All right, let's talk about logs. You do have probably a handout for this, but you could also just jot it down in your own notes. And so a logarithm, it's a special way to ask a specific question. And we're going to talk about that question, but first let's talk about the format of a log. And so when you have a log written, notice this little b, that is a sub-value. So notice how instead of an exponent raised, it's lowered. So make sure that when you write that, that's very clear. And then we have a value of a and equal to x. And so we would read this, okay? How we say this matters. The log base b of a is x. We're used to is, that's equals, but this part right here sounds different. Be careful, the word of does not mean multiply. This is just how we read a log. And so let's talk about once I know how to say it, why do I need it? And so the question that we're going to answer and use is what exponent is required to go from a base of b to reach a value of a. So we're answering a question. For example, if I said, what exponent is needed on 2 to get to 4? You would just say 2, right? And we've talked about other ways to use that. But what if I change that to a 3? What exponent is required to go from a base of 3 to a value of 4? You don't know. And so because we don't know the exact value, we have logs to help us get there. And so let's talk about exponential form. Here's what you're used to. You are used to a base that has an exponent and it's equal to a value. That's what we know, but I'm going to color coordinate. So if you have colors, maybe consider doing that as well. We are going to convert that to logarithm form, which looks like this. Notice the color coordinating. So for me, instead of trying to memorize 3 different pieces of information, I memorize 2, and this is just my little trick. The base becomes the base. Right? We can think of, there are 2 different types of bases, but that does make it easier to remember. The base becomes the base. And I always remember the exponent becomes the answer. Or vice versa, the answer becomes the exponent. If I can remember those 2 things, then the additional piece just falls into place, right? It's easy to fill in the blank from there. And so you're going to hear me say that. The base becomes the base, the answer becomes the exponent becomes the answer. And if you come up with a different way to memorize that, that's what you need to work on. Okay, how are you going to memorize? Is it maybe for you writing an example each time? Maybe you're going to write it like this because it's something that you could check each time. Right? Both of those we could check in our calculator, right? Because they're clean numbers. So you got to decide, are you going to remember the words? Are you going to remember 2 of the pieces? Are you going to remember an example? Well, what do you need to do? All right, so let's talk about, there's all kinds of logs. So first of all, this is the first one we just talked about. The base became the base. The exponent became the answer became the exponent, and you have to be confident in rewriting both directions. Okay, so let's talk about this next one. This next one, it doesn't have a base, right? There is no little a here. So what if there is no a? And we'll take note of this. If there is no a, that's called common log. And common log is a base of 10. So if there is nothing there, you assume a 10. We're so used to assuming ones, so that's going to be a bit of a change. If there is no base, it's 10. Okay, that's called common log. That's the common. That's what your calculator naturally does. Natural log. Natural log. I know it's ln, which seems backwards, but it stands for natural log. The natural log, there is no base, right? If there's no base, that's because the base is e. Natural log, the only time we use it is with a base of e, which we've spent time previously learning about. Okay. Other than that, the base becomes the base, the exponent becomes the answer. All of that remains the same, but you have to remember the e piece. All right, so we're going to practice calculating these, some by hand, some by using our calculator. But if you are using a scientific calculator, first of all, if you have a graphing calculator, a lot of times if you look in the menus, you can get this log, which is nice, right? You just fill in the two numbers you need and you move on. But if you're using a scientific calculator, you're not going to have those fill in the blanks. And so we also have to talk about how can I use this if I don't have a log base key? Then you're going to use the change of base formula. Let me add that little detail. This is called change of base formula. And what you can do is you can use common log, meaning the larger number, or think of it like the top number, divided by log of the small number or the bottom number. You can split those up into two logs, which then allows you to use a scientific calculator. Okay. And so I'm going to practice converting and I'm going to practice change of base formula. So for this first example, I'm wondering what this is, right? I don't know what this is. So let's say equals x, equals unknown, right? The base becomes the base. The answer becomes the exponent. Therefore, what's remaining? Notice if I convert it, that's super easy to figure out, right? Now we just use our tables or our calculators for basic exponent work, and we find out that it's equal to 3. So try this with a scientific calculator or try it with your graphing calculator. Graphing, you're going to go to math, and then you're going to go down to log base. Scientific calculator, I could type this in, but you'll have to close your parenthesis before you type the next log, which should also get you to 3. Okay. So some of them, we're going to start off, you could just mentally calculate. Some of them, you'll need a calculator. So for example, let's go to this next one, log base 6 of 216. Are you going to type it into a scientific? Are you going to convert? What are you going to do first? I'm going to say 6 to something equals 216. Remember that roots card we had? You could use your roots card for that, right? And we're going to get an answer of 3 again. ln of 4, that's natural log. Natural logs have a base of e, we just don't write it. And we don't know what it's equal to. So e to what exponent equals 4? I have no idea, right? And nor do you need to. This is a straight calculator problem. Straight calculator because it's base E. And so what I need you to do is go find that key on your calculator. We're going to say approximate because we are going to round. The ln key, if you're using your graphing calculator, is bottom left down by E. Just type ln of 4. And I always say 3 to 4 decimals. You can round or truncate that fourth one. So practice that on your calculator. All right, the next one, I don't know what this is. I'm going to try converting 3 to what value is 1 over 243. Okay, I can get from 3 to 243, right? That is an exponent of 5, but what value kicks the 243 to the denominator? A negative 5. A negative 5. Again, practice typing in your calculator if you need. 5 to what exponent is 125? See how some of these are easier if you just do the conversion? I think it's faster than typing in your calculator. ln of e. Ooh, type that in for once. ln of e. So if there is no exponent on the e, you assume 1, right? So when you go to type that in, your calculator will likely put a parenthesis there and prep your box like that. We got 1. Why is that? Okay, well, let's talk about why that is. Because what's the base of ln? E. E, the base becomes the base. What exponent gets me back to e? 1. Or also notice if these values are the same, that's a unique relationship. Okay, we're going to keep exploring, and sometimes your calculator can help you out. So again, we wanted to reiterate this. We had this previously in our table on our notes, but remembering that common log. So if I ask you to evaluate log of 100, we're really thinking of it as log base 10 of 100. And if I say 10 to what exponent gets me to 100, that would be a 2, right? And so just knowing that's called common log, you have to assume the 10. All right. So when is the calculator not helpful? When I ask you to convert without any actual values, I'm going to give you a bunch of letters here. So let's start off with this first one. If it's given in exponential, we want to convert to log. If it's given in log, we want to convert to exponential. So let's start with logs. The base becomes the base. The exponent becomes the answer, and therefore y is my main value. I'm going to go down the left side first. E becomes ln. The base becomes the base, the exponent becomes the answer, therefore we're finding x. Now typically, you don't write that little e, okay? Just ln of x. Log, the base becomes the base, the exponent becomes the answer, therefore I've got a main value of x. Make sure your bases look tiny. Make sure they look like bases. Let's do the opposite. Let's convert. From log to exponential. The base becomes the base. The answer becomes the exponent. Therefore, what's remaining is my answer. The base becomes the base. The answer becomes the exponent. Therefore, what's remaining? Now, if you have a fractional base, please use parentheses. That's required. Otherwise, that y looks like it's only to the 7th. So make sure you have that written with parentheses. All right, ln. ln has a base of e, right? So the base becomes the base. The answer becomes the exponent. Therefore, equal to u. So look at those problems. How are you comfortable memorizing this? What is going to be your trick or your way to remember? All right, so let's take this a step further. Why are we learning this? Because in the end, we want to solve equations and we want to find values of x. And so what we learned in a previous lesson was how to make common bases. Well, that worked great. Common base of 2, right? And then we said, oh, 2 to the 5th gets me 32. And if we have a common base, then we have a nice clean equation, right? So previous lesson, see my other video for that. So what if I can't get a common base, right? What if I can't? I can't take 2 to any power and get 100. That's why. If common bases are not an option, that should say base. If common bases are not an option, that's why we have logs, because now we can use our calculators. All right, so let's practice. First and foremost, like always, you need to isolate the main function. Rewrite the problem where all the Algebra 1 work is done. We know that there's no nice pretty value of x that gets me to 7, so let's convert. Here's the new stuff. The base becomes the base. The exponent becomes the answer. Now it's a calculator. So again, go to math on your graphing and go down to log base and fill in. Or if you're using a scientific calculator, you can type in change of base formula. I'm going to practice change of base because I want you to be comfortable with that option. Make sure you close parentheses. And we're rounding, so I do expect approximation signs and I do expect 3 to 4 decimal places. All right, let's try another one. Take care of the Algebra 1 work first. So let's rewrite this. So 14 plus 5 is 19. 19 times 2, instead of dividing by a half, gets me 38. So this is my actual problem, right? Let's convert, because there's no nice pretty number that I know how to get to 38 with. So the base becomes the base. The exponent becomes the answer. Therefore, what's remaining is my main value. This is log base 10. This is common log. So on your scientific calculator, you could just type log of 38. Okay. Same with graphing calculator. If you just use the log key that's present, you can do log of 38, enter that. It's going to get you crazy decimal. Keep it in your calculator. Okay. And then minus 3 from it equals, and then divide by 2 equals. You need to know your order of operations. X is going to be approximately negative 0.7101. So minus 3 equals, divide by 2 equals. Make sure you're comfortable with how to use that in your calculator. All right, isolate the function first, so let's just kick that 4 over. Now we're ready to convert. E becomes ln. The base becomes the base. The exponent becomes the answer. We've got our main value. Now we know when we type it in, we don't need the e. So in your calculator, just straight type ln of 8. Whatever that is, subtract 2. X is approximately 0.0794, right? It should be a lot of calculator work. You're only showing me the basic conversions. I do have some extra examples. If you are using my foldable, I strongly recommend you jot these down in your own notes. That way you have a few other examples to look back on. So first, let's isolate the function and rewrite the problem. I'm going to minus 1, divide by 4, we get a pretty 1. Now, some of you might know this answer. Some of you might be in robot mode. So if you're in robot mode, log, the base becomes the base, the exponent becomes the answer. I want you to type that in. If you don't know what the answer is, I need you to type in log base 3 of 1. Give you a second to do that. Yeah, did you see what happened? Does that make sense? Go back to the original question. What exponent will always get me an answer of 1? 0, right? But if you're in robot mode, you're going to do this. And then if you divide, you're going to get 0. 0 is an okay answer. Be comfortable with that. And check your work. How easy is that? It's easy to plug it back in and make sense of that 0. Let's try this one. Let's rewrite the problem first. Let's kick that 1 over. I'm going to convert. The base becomes the base. The exponent becomes the answer. Okay, if you're using scientific, do change of base formula. If you're using the math key on your graphing calculator, then type in that base correctly. Crazy decimal, and then let's just, whatever you get, keep it in your calculator, and then add 2, plus 2 equals. So I'm getting x is approximately 6.0331. Now, I mentioned checking your answers. You can check your answer, okay? You have this answer in your calculator, right? So if I go to check my answer, 3 to the, and we want to use answer, previous entry. If you do second enter, oops, not sorry, second enter, sorry, second negative on the graphing calculators. It pulls up the previous answer, put a little minus 2 in there, and then get out of the exponent and plus 1, and it'll give you exactly 85. Okay, so practice typing that back in. Do you know how to do that? 3 to the, we want the A and S key, minus 2, and then get that big plus 1. Right? If you need me to show you that in person, let me know. All right, let's do some Algebra 1 work first. Let's rewrite the problem. We need to minus 7 first. We need to divide by 3, and you might be thinking, Mortvet, that does not divide nicely. Correct. Leave it as an improper fraction. So we're going to keep it as 26 thirds. Keep it exact, please. All right, let's convert. Log, base, value, exponent. Right? You should be able to convert that quickly. Get comfortable with that. Now, we wanted to do a fractional one so that you are comfortable with how you type that in. If you're doing change of base formula, 26 slash or divide by 3 close, then divide by log of 2. Are you comfortable with that? That'll get you a crazy decimal. Keep it in your calculator. And then let's go plus 5 equals and divide by 5 equals. Order matters, order of operations. I'm solving these with you, approximately 1.6230. Yep, I can check this. Keep it in your calculator. 3 times 2 to the second negative answer, a times 5 and a minus 5. Get out of the exponent, plus 7. You should get 33. You can do that in your scientific calculators as well. All right, so I'm going to say first and foremost, the main thing is get comfortable with converting. You need to have that memorized. The solving piece will come more naturally. We've done so much solving this year, but you have to know how to convert logs to exponentials and vice versa, and you need to how to convert ln's and e's. Okay, work on memorizing that. As always, check out Google Classroom, see what the task is, and until next time, have a good one.